This content is AI generated for informational purposes only and should not be directly used for clinical decision-making.
Hello and welcome back to the Neurosurgery Hub podcast. I'm Dr. Eris, Senior Attending Neurosurgeon.
And I'm Dr. Alara. Today we're looking at a fascinating new study from the journal World Neurosurgery 2026 titled Evaluation of a 3D Simulation Model for Unilateral Biportal Endoscopic Lumbar Discectomy, a validity study in residency training.
This is a timely topic, Alara. Unilateral Biportal Endoscopic Surgery, or UBE, has really gained traction as a minimally invasive technique for lumbar spine pathologies. But as anyone who has picked up the endoscope knows, the learning curve is notoriously steep. It requires a completely different set of hand-eye coordination skills compared to open or even tubular microscopic surgery.
Exactly. And that's the core problem this paper addresses. Because the learning curve is so steep, we need structured training before residents ever touch a patient. The authors of the study developed a 3D simulation model for UBE lumbar discectomy and put it through a rigorous evaluation using Messick's validity framework.
Messick's framework is the gold standard for educational validity. It doesn't just ask, is this a good model, but looks at multiple sources of evidence: content, response processes, internal structure, and relations to other variables. So, Alara, how did they set up the simulation?
They created a high-fidelity 3D printed phantom. It wasn't just a plastic bone. It used silicone-based soft tissue to mimic the ligamentum flavum and the phacal sac, and it featured realistic bony structures and a herniated disc. The task for the participants was to perform a full UBE procedure: the flavectomy, the decompression, and finally the discectomy.
And who were the test pilots for this model?
They recruited 25 participants and divided them into 3 distinct groups to test what we call construct validity. Group 1 was the novices, 9 residents from PGY 1 to 3. Group 2 was the intermediates, 9 residents from PGY 4 to 6. And Group 3 consisted of 7 experts, defined as surgeons who had performed more than 100 clinical UBE cases.
That's a high bar for the expert group. Over 100 cases means they truly understand the nuances of the biportal approach. What did the data show when these groups went head-to-head on the model?
The results were quite striking. The study found significant differences across almost all metrics. First, let's talk about relation to other variables, which in this context means, does the model actually distinguish between a beginner and a master? The answer was a resounding yes. The experts were significantly faster and demonstrated much higher technical proficiency.
Did they use standardized scoring systems?
They did. They used the GRS, the Global Rating Scale, and the OSATS, which is the Objective Structured Assessment of Technical Skills. The experts scored significantly higher than the intermediates, who in turn scored higher than the novices. This confirms the model has strong construct validity. It accurately reflects the surgeon's real-world experience level.
I think the content validity aspect is also vital for us as attendings. If I'm going to use this to train my residents, I need to know it feels real. What did the experts think of the model itself?
The experts gave the model very high marks. The mean score for content validity was 4.6 out of 5. They specifically noted that the haptic feedback from the 3D printed bone and the ligamentum flavum was realistic enough to provide a meaningful training experience.
Let's dive deeper into the workload. I noticed they mentioned the NASA TLX. For our listeners who might not know, the NASA Task Load Index is a subjective, multidimensional assessment tool that rates perceived workload. Why is that important here?
It's crucial because UBE has such a high cognitive and physical demand early on. The study showed that novices reported significantly higher mental and physical frustration levels compared to the experts. As proficiency increased through the groups, the NASA TLX scores decreased. This suggests that the model effectively simulates the stress and effort of the actual surgery.
What about reliability? If 2 different attendings watch a resident use this model, will they agree on the score?
The study reported high inter-rater reliability. This means the scoring system, the GRS and OSATS, is robust. It's not just a subjective gut feeling by the evaluator. The model provides a consistent framework for assessment.
This is a big step forward. One of the hardest parts of teaching UBE is that the lead surgeon and the assistant are working through 2 different portals, the endoscopic view and the instrument portal. It's a triangulation challenge. Having a 3D model that allows a resident to fail safely during the decompression phase before moving to the clinical setting is a game changer.
Absolutely. The authors conclude that this 3D simulation model is a valid and reliable tool for UBE training. It fits perfectly into a competency-based medical education curriculum. Instead of see one, do one, teach one, it becomes simulated many, then do one.
It's about patient safety at the end of the day. Using Messick's framework to prove this model works means we can trust these simulation scores when deciding if a resident is ready for the OR.
Well, that's our deep dive into the 2026 World Neurosurgery paper on UBE simulation. It's exciting to see how 3D printing and formal validity frameworks are evolving our surgical training.
Thank you, Dr. Alara, and to our listeners, keep practicing, keep learning, and we'll see you in the next episode of the Neurosurgery Hub podcast.